Hello, I'm Paweł Murias, and I'm here to talk about compiling Perl 6 to JavaScript. So the first question we should ask ourselves: why are we even doing that? And it's a complex. There's a complex answer to it, and the first sub question is: why would we ever want to run something on JavaScript in the first place? And the most obvious answer is that browsers run JavaScript, and web browsers are everywhere, and nobody wants to install programs on their computers anymore. But there are more, or perhaps probably, or sometimes less interesting uses for JS too. It's getting almost everywhere. So, whatever new appliance is invented, people want to install JavaScript on it, even when it's not suitable in the list. So one important application is that there's something called React Native, and it allows you to write JavaScript that runs on Android and iOS, and probably also in your terminal. There's React Blast, which allows you to write your JavaScript classes of apps. And if we compile JavaScript, we will be able to run on Android without porting our more VM. So that's one interesting use. On the backend side, the most common way to run JavaScript is Node.js. I'm using it for development mostly because it allows me to run stuff from the terminal without firing up a browser and tests. And one interesting property is that there are tons of modules that on NPM, and most of them are not usable for anything, but a large, probably a small percentage, but still a lot of them are useful. And inline Perl 5 uses native call, so if we implement a few foreign function interface ops, you will be also able to use Perl 5 modules on Node.js if you can't find anything on NPM that works. So it will be possible to use both LeftPad and CGIPN in the same program. Or something more reasonable, hopefully. And while Node.js mainly runs on the V8 right now, other VM vendors are wanting a piece of the cake too. And one interesting thing is Chakra Core, which is the JavaScript virtual machine Microsoft uses. And it's in the Edge browser that probably nobody heard of. But the killer features they are trying to promote themselves with is time travel debugging. So instead of spending your day stepping forward, trying to find where the bug is, and probably stepping more than you wanted to, you can run your test suite, find the place where the error happened, and just debug away back in time. And so that's something that we, the Perl 6 guys, like the Masak was creating his own interpreter with which we all stepping back in time, and it was a complicated process. And when we run on Chakra Core, we get it basically for free. So the Oracle also implements its own Node.js. It's called Growl.js, and once that would mean that we'll get a JVM backend for free. It might not be the fastest thing in the universe because we have 2 layers in direction, and we already have one. But if it's free, so we can take it. The other common thing that actually Perl 6 runs on from a few days ago is Electron. So it allows you to write your desktop applications using the web technologies. They might be slow sometimes, or probably always, but it's a nice nice way to put a UE app on your Perl 6 program without learning Qt or whatever. I'm not sure what it is nowadays. Also, some of the most recent editors like Atom.js and Visual Studio Code are extensible in JavaScript. So if we compile Perl 6, we can write our own editor plugins in it. And that's probably something that we need. Like a lot of people like IDEs, and I use Vim myself, but it will probably be helpful for others. And in terms of stuff for children, VI is embeddable not by default, but you can embed it in it. For example, the Unreal game engine. So instead of writing an asteroid clone using SDL or whatever, you can easily create something that looks really modern, like a 3D proper game, just by using the Unreal Engine and some assets from the internet. Lots of people start programming that way. So it's cooler. And now that a second much more harder question is, why not just use raw JavaScript itself? Is why compile something and have an indirection layer or extra bugs? And it's not as crazy as it sounds. Like people in JavaScript land compile stuff to JavaScript so much they invented a strange word for it. So everything is like a transpiler nowadays. People are even compiling JavaScript to JavaScript. Like it's the state-of-the-art solution, and they do it because it allows them to use new features on old browsers, or super new features on new browsers. And the other reason is that some people don't like JS, and it's probably another statement. And I'm not sure what the reason for it is, frankly, but it's probably that they're being forced to it by necessity, not by choice. I personally like JS. I just consider Perl 6 is just more awesome. So, no. And fun matters. Like, if you want people to do it in spare time, it must be fun. And even if people are doing it for profit, they are more productive when they like it. A harder, more technical reason that it will allow you to have your backend and frontend in the same language. So they call it isomorphic JavaScript. It's unrelated to the isomorphism in mathematics. And so we will have something called isomorphic Perl 6 now, which sounds cool and sophisticated.
And cool is important.
Yes, and we all use share code between backend and frontend. So you don't have to rewrite stuff twice, which is super unfun. So how are we doing it? Implementing your own Perl 6 compiler alone is a ton of work, and you spend a lot of time doing things you are not interested in. Like, so I tried it before to maintain both a VM and my own pet compiler, which didn't support everything, and I don't want to do it again. So a solution is to write a backend for Rakudo. Rakudo is that's a maintained and has a vibrant community that is always pushing things forward. And sometimes I just and there's some parts of my effort for the JavaScript also improve the main compiler. So it's even if I fail or I'll still bring it forward. An important thing to understand how Rakudo works is that it uses two languages. There's something called NQP, which is not quite Perl, and it's a simple Perl 6 subset that's only advantages that it runs faster, so that's why Rakudo is written in it, so we don't have to wait hours when we can compile. And there's Perl 6 proper, which is a full language. And For the backend, I'm mostly writing it in NQP. Both of those languages are compiled to something called QAS. The Q letter doesn't mean anything, it's just an improved version of PAST, which was, I presume, Parrot Ast or maybe something else. And QAS is compiled to JavaScript. So the same backend is written for both of these languages. Here's an example how QAS nodes are constructed. So they're based on, most of the nodes are fairly simple. Some of them are a bit esoteric. So here we have a new statement. It's a test, like there are many of those. A large part of the effort are all the NQP ops. So a bunch of them are fairly simple, like this one which adds to integers. So the backend mostly consists of implementations for right now probably almost all of them. Some of them are more complex, like this one that allows you to invoke foo with a code ref. This is an internal data, you don't have to understand that right now. Here's an example how it ends up in a QAS node. So all the opcodes are an opt3 node. Usually when I implement things, I write tests before doing that. I have to do it because I'm not Jonathan, so I don't know how everything works straight away. And hopefully this will help future backends, or likely even the maintainers on the current ones. So they won't have to debug some esoteric error. Just know what the ops are supposed to do. There's some documentation for the ops and for the tree nodes, but some is missing. And texts are better than documentation because you can run them. So here is an example of the simplest test. There was actually a bug in mod in the modular operation because it was running differently on JavaScript than Rakudo, so even simpler ones can help. Sometimes when I build all the small opcodes and AS nodes, complex stuff works. Like junctions work that way, so I didn't have to implement all the tricky details and read the specs, study the specs. I just implemented some ops, some hook, and it worked. But it doesn't always happen like that. Often, if I misunderstand some small detail, I spend hours looking at a huge generated Rakudo.js and search why things are behaving beyond weirdly. And most of the time, the solution is to tweak a line or two, and things come back to the same. Okay. One interesting problem is how are we going to debug our Perl-6 programs once they are compiled to JavaScript. In the past, the experience was horrible for people. And nowadays, we have something called source maps, which allow you to, instead of looking at the generated code, they show you which part of the program is the zero error corresponds to. And support for the source maps was designed from the start. Well, to be fair, it was from the start of the rewrite. Let's see. So basically, we generate an intermediate tree format which contains references to the parse nodes. I'm not going to show you because it's boring. I don't even look at the intermediate format dumps myself almost ever. There's not even an option to see them. native types are important, especially for QP where they are everywhere. And our intermediate format is called chunks. Also support for that. So when we have something like adding two integers, it's hopefully will be compiled to add I opcode. And in GS land, where it will look like that. The XOR O is a pattern we borrowed from AskJS, because JavaScript itself does. Okay, that means if somebody has any questions, I can answer them.
Could you show the code before once again?
This one.
Okay. What's this pipe thing?
It's an.
It's a hack.
It's XOR, which is a feature.
Oh, so that forces it to be native or something?
It forces it to be an integer, because JavaScript doesn't have integers.
Okay. It's a hack.
Yeah, like it's a convention that was very widespread in all the implementations because of AskJS. So when compiling C stuff, it was a hack to allow you to use integers, and the VMs like it.
Okay.
Okay, so here's how we continuations were a tricky thing. Okay, so what's it?
You solved it?
Yes.
Show me.
It's not. Oh, okay, I'll show you, and then we can start running the live demo. Which is so the ones in the continuations in Perl 6 are really one-shot continuations, which are known in the civilized world as coroutines, and they're easier to implement efficiently. So here's an example of gather and take, which is just in every lazy list uses continuation, coroutines, continuations, however you want to call them. And on the Node.js, we have a fibers module, which uses libcoro or something equally as stable underneath. And it's a browser with Sprinkle, await, async everywhere. So once we have async await, we can suspend the execution using a promise. So once we call resolve, the execution will come right back. There's some a bit more details internally, but I don't want to bore you showing you slides of code. You can check them out on GitHub or talk with me if you want to check the details. And that brings us to an interesting observation that JavaScript is evolving towards becoming a better Perl 6 target. And most of the new stuff is helpful to us. So like the async await allows us to easily implement configurations. Like they added Unicode normalizations which we use. So everything is coming together. And here's the what's done section. And we passed 55% of roast files on Node.js. So
55,000 tests, right?
I would have
69,000 at the moment.
test assertions, yeah, probably. I count only call passing files.
Sure. So those are completely passing files.
Yes.
Yeah, not regardless, not counting how many tests are in each file.
That's good.
Yes. So I don't count things that sort of work sometimes as working. So, and there are some hard bugs which require some good night's sleep. So here's actual documentation of how closures are serialized and yeah, because MoreVM does some runtime fixing of closures, and that's stuff that I need to fix entirely instead of implementing exactly how quick. And there's some assorted bugs and some Unicode things that I need to load the file with the properties and things like that. And the challenge, what are the things that remain to be done? And performance is the big problem. Like it's shared universally across all backends. And I haven't really dug down that deep into Perl 6 performance itself, because I want to understand fully. It's a typo. What's needed before I start bending the semantics and doing some optimizations. And the performance of the compiler and the user programs are two different things, because we have the compilers written in NQP and the users what will write Perl 6. And the good thing about NQP is that we can tweak the semantics. And we don't want to tweak Perl 6 semantics, or even if we could, we don't, we shouldn't, just for the because I know the JS backend can handle them. And also the code size delivery is a problem we should address. And most of the other languages use something which is called tree shaking, which is basically making a graph of what uses what and getting rid of the dead code. Okay, so how much time do we have left now? Oh, it's time.
I wrote a tree shaker in 1976.
And then people can stay. We have a 30-minute break.
Yes.
People can stay, but if you can just end the talk.
Okay, so thanks a lot for coming to the talk. Hopefully, if somebody is interested in the backend, the best way, even if you want to check it out, is to contact me on the Freenode Perl 6 channel, because things might not be fully working at a given moment. And if you ping me, I'll make sure they are. And that's it.